Well, welcome everyone to the October 2020 meeting of the Mississippi PowerShell user group. Tonight we have Josh King with us, and he'll be presenting Azure Durable Functions. Take it away, Josh.
Awesome. Yeah, thanks for having me tonight, or this afternoon. Tonight I'm talking about Azure Durable Functions and how PowerShell is a supported language in there. I'm Josh King. I'm a sysadmin at Tribe. We're an MSP down here in New Zealand, and I'm also a Microsoft MVP. I'm on Twitter at WindowsNZ, and my blog is toast.click. So we're going to go through Azure Functions in general, then we'll have a bit of a demo and then expand into durable functions. So starting with standard functions, they are a service in Azure which allow you to run small pieces of code without having to worry too much about the underlying infrastructure sitting underneath them. And they can be triggered by a list of given events, like you can call them via HTTP, you can have them on a timer, that sort of thing. I like to think of them as sort of the evolution of the script host that I used to have sitting in our virtual environment. So of course that machine would literally just sit there running PowerShell scripts in the task scheduler. And for the most part at work, I've managed to move all of my scripts into Azure using functions and other services. And it's using less running costs than the Windows license I was consuming. So yeah, win-win. Now, the question I often see about functions is, but it's just for devs, right? And if you're looking at the supported language, you'd probably be forgiven for thinking that. The list of supported languages includes a lot of stuff you'd expect to see, like C#, JavaScript, Python, all of that. But of course, there's also PowerShell. And then that enables us to run our scripts, like I was saying, up in Azure. So for the demos today, we need to lay a bit of groundwork, and in general, to use this stuff, there's a bit of groundwork to cover. First, you do need an Azure account. If you need to, you can sign up for a free trial, and toast.click/AZ trial will take you through to where you can sign up for that trial. We're going to be using Visual Studio Code, and within there we need the Azure Functions extension. And we also need the latest version of the Azure Functions core tools. I use Chocolatey to get that installed and updated, and of course the command to run that is shown here. This -3 on the end is important. PowerShell was supported in version 2, but in order to use durable functions, you need version 3, and hence the -3, because they're separate packages on the Chocolatey repo. So let's dive into our first demo. Now, these are pre-recorded because unfortunately there's some bits that just can't be sped up. There are bits in here that benefit greatly from being sped up. So we're actually starting in the Azure portal. And that's because there's a bit of a lead time to getting your Azure functions up and running. So I do it in the portal, then I can flick over to VS Code and do it from there. You can create your functions app from VS Code when you're first deploying them. It's just, you don't have quite as much control as you would otherwise. So from the portal, search for function app. You'll find it in the list of services. And once you click into it, you'll see your list of existing function apps if you've got them. And to create a new one, click add. And of course it thinks for a little bit and then pops up the screen for creating a new app. Now, you need to select your subscription. I've already got the one that I want to use there. And then you need a resource group. So you can click the list and pick one that you've already got or create a new one from here. Of course, to keep things tidy, create one that's specific to this demo. And then you need to give your function app itself a name. This needs to be globally unique because it's resolvable across the internet. So you'll see it thinks for a bit, then there's a green tick mark, and the full name is what you specify there, .azurewebsites.net. Then need to click pick runtime stack. Obviously for us, that's going to be PowerShell core. And then the only version that's available is 7.0. So 6.0 used to be available, or 6.1 or 2 or whatever it was technically, but that's been deprecated now. So 7.0 it is, and pick a region. For me, Australia East is my closest data center for the moment. So I pick that. Now go through to hosting. Does need a storage account. I click create new because I don't like the automatically generated names. So give it a name, click OK. And we're going to be doing everything on the consumption serverless plan. It's nice and cheap, although it has its limitations, which we'll run into later. I do enable or keep enabled application insights. And again, I don't like the name that it defaults to, so I create a new one. It's really hard to troubleshoot some of the stuff without application insights turned on, so leave it on. We go and validate it. You can scroll down this list and check everything's right, but if you're happy, click create and it goes off and thinks about it for a while. So while that creates, we head over to VS Code, and you can see I've got the Azure Functions extension there already installed. Yeah. And you'll also want to have the PowerShell extension. I use the preview one, but you can use the stable one as well. So once you've got the Azure Functions extension installed, you'll have a little Azure icon on the left-hand side of your screen there. And if you click into that, I'm already signed in, and I know that because I can see my subscriptions listed there. And if I wasn't hiding it, you would also see the email address that you logged in with in the status bar down the bottom. If you weren't logged in, there'd be a link there to log into Azure, and that opens up a web page, and it's just standard, log in with the account that you want to associate. So having been logged in, we need to create a new project, and in a moment I'll go and click that button. So it's this little folder icon with the function apps lightning bolt on it. If you click that, it spins up a new project, which the first step is picking the directory it'll be saved in. I've already got a directory I'm already in the directory that I want to use, so I'll just pick that from the list, but you can browse and then through that create a new directory if you need to. I'll pick that one. And again, you're asked for the language, so for us, PowerShell. Now you'll notice, so go and click it, it doesn't ask me for the version because 7's the only valid answer. Now, it does ask you to use a template. This will create your very first function within this function app. But I'm going to click skip for now so that we, because we'll come back to that in a sec. So it thinks for a little bit, and then it scaffolds out our project. So if I head over to the Explorer view, I can see a bunch of files now, and we'll work our way up some of the interesting ones. So the first one's this requirements file. In here, you can list any PowerShell modules that are available on the gallery that you want available to your functions. By default, it's got the AZ module there. That's huge, and it takes ages to install into your function app, and we're not going to be using it, so I just delete it. So if you did have functions, say you wanted one of the Twitter modules because you're going to be tweeting from this function app, or you want the Microsoft Graph functions, the modules. You can list them there and they'll automatically be installed for you when your function app starts. Then there's this profile. By default, it has some code there which only runs when you've got the Azure PowerShell module, and we won't have that module, so I commented out. Now, this is just a standard profile like you'd find on your machine. So if you wanted to create aliases or variables that are going to be available within all of your functions, you can define them here, and the profile does run every time there's a cold start, and that's the first time or after there's been some activity and it needs to warm back up. So I don't remember if I click into any of these. I don't think any of them are very interesting. Oh yeah, there you go. So the version numbers, PowerShell 7. In an older version of the core tools, this was left out and you had to add it manually if you wanted to run your functions locally. But good news is there's been an update and that doesn't happen anymore. And then, yeah, we're not going to be doing any. Interestingly, if you did want, in this host.json file, if you did want to completely turn off managing the dependencies, which are in your requirements file, you can switch this over to false, and it just turns that function off in its entirety. So we're going to create first actual function now within our function app. And so I've pressed Control-Shift-P to bring up the command palette, and then I'll search for function. And the top option there is Azure Function Create Function. So we click into that, and it's going to present that list of templates again. So for this demo, I'm going to pick the HTTP trigger function, which is a template, which is a function that you can call by running invoke REST method against a URL that represents that function. So we'll click on that. I have to give it a name. So I think I call it func standard or something to that effect. Yep, func standard. And then you're asked for an authorization level. For the ease of demonstration, I pick anonymous, and that's just so I don't have to worry about keys or anything when I'm calling my functions. All of this already has been torn down, so you can't go and try and call it. So I've clicked the template and it's generated a function for me. It sits under a folder with the name that I supplied. And you'll notice this particular template has a sample.dat file, which we're not going to use, so I delete it. Now, the run.ps1 file is the actual function. It's the PowerShell that executes. And it's actually a really nice template that shows you how all of this stuff works. So if my mouse wants to start moving on there it goes. I'll do it myself. So coming into the function, there are a couple of parameters. The one that I've never actually used the trigger metadata yet, but the request has information about the request that, the request that triggered this function running. So if we jump down here, there's an example of passing a name via either a request query or request body, and then storing that in a variable. Then it changes, so sets a body message, which is just a string saying, hey, pass through a name. Then if we happen to have actually got a name, it changes that to something more personal. So it says hello name, and then it outputs the result. So the command that it uses to push the result back out is push output binding. And in there is a status code and body, which is either this generic thing or this personalized thing. So these HTTP status codes can be, well, any of the valid status codes, I guess. So there's things like OK and no content and all of that. But we're not going to be using half of this stuff, so I'm going to change it. I do make the status code a variable so that I can change it in the body of my actual function code rather than having it hard-coded there in the response. And the first thing I'm going to do, I guess I should probably explain the goal of this function. So this function, when you call it, you pass in a list of addresses. Could be IP addresses, could be DNS names. And then we're going to iterate over all of those addresses and test to see if the SSH port is open. And then we'll output an object for each of them with the address and the status of the port. So we're going to start by collecting our list of addresses. If I want to keep typing here, there we go. So my addresses are coming from that request parameter under the body. And in this example, I'm only taking them from the body. I'm not accepting them as a query string, just to keep things easy. Mm-hmm. Oh, right. So if this happens to get called without supplying I think I just realized I typed that wrong. So if I run this without supplying an address or list of addresses, we want to respond saying, hey, look, you done goofed, try again. So my body is going to be, please pass an address on the request body, in the request body. And my status code will be bad request. Come on, type faster. So you'll see that list that fired up there. Not quite there yet. So you do get IntelliSense for all the different types of status codes that you can respond with. So there is OK in there, there's bad gateway, bad request, all of that sort of stuff. So for this one, I'm choosing bad request. So now if we called this without an address, it's going to respond with, hey, remember to supply an address, and it'll have an error code against it as well. Now, if we do supply an address, we actually need to go and do the work that our function's actually designed to do. So we'll run a for each loop, which iterates over all of those addresses. We'll call each iteration target. So we've got for each target and address. And then for each target, and I'll explain why I'm using try in a second here. So we're using test connection. We target our target, obviously. And then the SSH port is TCP port 22, so I supply that. And then I need this try block to actually catch errors, so I set my error action to stop so that it's actually a terminating error and ends up in being caught. So the reason for that is when I supply a target here, it's going to try and if it's a DNS name, it's going to try and resolve that name to an IP address. If that address doesn't exist, it errors out saying, hey, the address doesn't exist. In that case, I want the output from all of this to be null, and I'm explicitly doing that in a catch statement in a second. if the target does exist and the port's open, it responds true. If the target does exist and the port's closed, it responds false. So then I've got 3 possible states. And regardless of the outcome, I set port open. So that one can be either true or false. This one is only ever null, and it's if my test connection triggers an error. And then finally, we return a PS custom object, which just has the address and the port open status. Target and port open. So what I'm going to do is the output from all of those PS custom objects I'm storing in a variable. And then once the loop's done, I go and set my body to the results. And of course, because it executed successfully, my status is going to be HTTP OK. And I think I forget what I'm looking for here for a second and search for success. Yeah. No, I've done goof. Yep, there we go. Okay. So let me, and what I happen to know is for one of my demos, I need this to run reasonably slow. So I put an explicit sleep in here to slow things down. And I initially put 60 seconds. Then I talked through this thing again. So we're getting our address from the request body. If we don't get it, we respond with that and a bad request. If we do get it, we loop through it, sleep for 20 seconds. There we go. And then we test connection against each address. It can either be true or false based on whether it's open, or if it doesn't exist, it will respond null. And then we output the custom objects. And then regardless of the result, we go push output binding with our status code and body. So if I'm not mistaken, that is this function completely done, and we can deploy it. So we head back over to the Azure extension on the left-hand side and click the little deploy to function app button. Now we could run this locally, and we probably should run this locally, but for the speed of demonstration, no, I'm going straight to deploying it. So when you click that button, you need to select a subscription. So I'll pick mine, and then it searches for function apps in that subscription. And we can see from the list there that my MSPSUG one has been created and it's available for me. So we'll click on that. And the first thing it'll do is show you a confirmation. It is important to note that this does overwrite anything that's already there. So do double check that name before clicking deploy. And don't ask me how I know that can be a real issue. So having done all that, it'll pop up down the bottom saying that it's deploying, and you can click that output window link to see what it's actually doing. So this will tick away for a little bit, but while it does, I believe I'm going to create a little script just to test how my function is running. So once this all finishes, we end up with a URI that we can call our function on. And then we can run invoke REST method against it. So when I normally do this, I speed up this bit so I'm not being distracted by it when I'm writing my demo up the top there. Oh well. So just as an aside, you do see the deployment completed thing down here, but the output's still working away. So what we'll see is in a moment, it is going to pop up the URL. So we can go ahead and copy that, and you'll notice the end of it is the same as the name of our function app. So I'll copy that, paste it in there. And if I run it as is, without any addresses, just literally querying the URI, it responds with, and that might be a little bit small and dark, sorry about that, but it does say, please pass an address in the request body, and it's an error. If we did look at the headers, we would see it being a bad request error code as well. So let's go and actually use this thing properly. To do that, we need a list of addresses. So I'll put my blog there. Hopefully I don't have SSH open on that. I'll also include an old address for my blog, which redirects there. Then there is a known fake address, which shouldn't resolve to anything. Then there's two services that I know of that do have open SSH services for training and whatever. I don't ask questions. But I'll include those so we can see some true results. And then finally, a couple of DNS servers, which again, hopefully SSH isn't open on those, especially given their Google and I'm forgetting what quad one's, Cloudflare. So yeah, those two I'm expecting true from. Everything else I'm expecting null or false. So now we need to actually provide that to our endpoint. So we've got our body, and I believe I mucked this up on the first try, but so I try passing in my address list directly on the body, and because we're passing in information, our method is now post rather than the default of get. And we need to provide a content type, otherwise it doesn't work, and it took me forever to figure out why. But we set content type to application/JSON, because spoiler alert, when I figure out what I've done wrong, I end up converting this to a JSON string. So again, it comes up with that error. Please provide a address on the request body. Then I clue into what I did wrong. Yep, there we go. I say, hey, okay, I need a body, and that is my address list. In a moment. Right. It's a hash table with the key address and then my address list. Otherwise, so remember in my function, I'm referencing .address. So I need the key there so it can be addressed. And then I convert to JSON. So now when I run this, it's going to tick away for a while, and I'm not getting a response back quickly to say that there's an error, so I know, hey, look, it's working. So while it's ticking away, I'm going to head back over to the Azure portal, and I'm going to show you the first issue that you might run into when you're using Azure Functions, and you start integrating them into other services. As soon as I decide to actually press Alt-Tab. Skip ahead a bit. There we go. So what I'm doing is I'm going to spin up a logic app which calls my function app. This is just to demo a particular problem, but it's really important to know about. So again, back in the portal, head into the search, click search logic apps and choose it from the list. You'll see your existing ones if you've got any, otherwise click add. Again, subscription and resource group. This time I can pick my existing one rather than creating a new one. Give it a name. This one doesn't need to be globally unique. Location, and for this one I'm keeping log analytics turned off just because I don't need it for the demo. So the deployment here is nice and quick. This is all real time for this part, and it's done. Now, when we first go into it, it takes us straight to the Logic Apps Designer because we don't have a Logic App sitting behind it yet. And we're going to start with a timer for this particular app. So I search recurrence. But I'm going to be running this manually, so I set it to something that's not going to trigger while I'm working on things here. So I set it to run every 12 hours, but I also start it in, I think, the start of December, so there's absolutely no chance of it causing any issues. Yeah, 1st of December at midnight. Done. So, first step on this is we're going to call our function app. So we can search for Azure function when I can spell it right. Comes up in the list, and I can see my list of function apps there. I'll click on the one I'm interested in, the MSPSUG, and it goes off and queries your available and valid functions sitting within that. And if so, at the moment I've got anonymous access turned on. If I did have some sort of keyed access enabled, it handles the authorization automatically for you, so that you don't need to stress too much about it. So I'll click on that. And I need to provide my request body to it in JSON format. So I'll go back over to code where I see, oh, look, it finished. There's my list of targets. There's my list of ports opened. I can see fake address is null. I can see those two are true and everything else is false. So awesome, it worked. Now I look at my body to see the JSON that we sent through, and I'm just going to copy and paste that into the portal. Done. Cool. Now, one final step is I'm going to put in a compose action here just to show a final step happening after my Azure function runs, and the input to it is literally just going to be the body coming out of my Azure function. So with those in there, I'll click save, then I'll click run. Now I do speed things up here a bit because this is going to take a while. So it starts, and you'll notice nothing happens for a bit. I think this is running at like 8 times speed, and nothing happens, nothing happens. We've got the green tick mark there, but nothing here yet until we get to the 2-minute mark, which should be coming up any second now. There we go. We get 2 minutes, we get this little waiting indicator, and my session's timed out. So this view here times out every 2 minutes, which is fine. We just head over to the run history and restart it. We can see it now ticking through 4 minutes, 5 minutes in a second. There we go. And we can see behind there, it says 1 retry occurred. Now, no matter how long we leave this open, that stays at 1 retry, but spoiler alert, it's actually more than 1 retry. So this is going to tick away for a bit. See, we're up to 9 minutes, 10 minutes, 11 minutes, almost there. And we've ended up with it erroring out. We've got a bad request, 4 retries. That's not good. And it ended up taking 11.3 minutes. The function itself only takes about 3 minutes to run. So that's obviously not good. So I've head back over to my function app and selected it from the list there. And then if I head into functions and choose it from the list, what I can do in here is go to monitor and see the past runs of this function app. But that looks like a whole lot of success to me. So, you know, what the hell? What it turns out is Logic apps and a lot of other services that consume APIs expect a response within 2 minutes. If it doesn't get that response within 2 minutes, it assumes something's wrong and basically abandons that previous attempt and tries again. And it'll do that however many times it's set up to do it. Logic apps is 4 times. Other systems might be continuous or whatever, but the output of this is never going to actually get back into the logic app. Now, this can be a real pain if your function is making system state changes, like potentially opening up help desk tickets. That process takes more than 2 minutes. You could end up with multiple duplicate tickets, which probably means there's issues in other parts of the code, but whatever. So what can we do? Whoop, just get that one ready to go. So what can we do to address that? Well, funnily enough, the answer is durable functions. So how are they different? Well, at the end of the day, they're just an extension that sits on top of regular durable functions. They enable stateful application patterns. Basically, there's additional metadata about your function, which can be queried and used to orchestrate more complex scenarios than just having one script that fires off. So I mentioned application patterns. There's currently 3 patterns that are supported with PowerShell. There's more available in durable functions in general, but just the 3 at the moment supported with PowerShell. The first one is function chaining. This one's fairly familiar. In fact, that diagram looks a bit like having a pipeline with multiple commandlets on your PowerShell shell. What this is you've got a function, its output is stored somewhere and then fed into a second function, that output stored somewhere and fed into a third function, so on, so on, so on. The chain could literally be 2 functions, it could be, tons of functions. That one's fairly easy to grok. Where things start getting interesting is things like this, and this is the namesake for this talk. It's the fan out, fan in model. As we've got some sort of input coming in, it spins up multiple instances of a function, which churns through whatever that input is. Then the output from all of them are aggregated and output. We will see this at the very end of the talk, but first, that wasn't what I was meant to press. But first, this is called the HTTP async pattern. It's a mouthful and it looks kind of complicated. It's not really. Effectively, what happens here is you call an HTTP function to start a given task. Then 2 things happen. Another function or functions are called which actually do some work, but there's also some information here about this orchestration. And what the user can do is, as a response to this, they're told, hey, here's somewhere where you can go and ask for the status of what you've just asked to happen. And that status might be running, and it could be running for quite some time, but eventually it'll say, yep, I'm complete, here's the output. So the thing doing the work stores the output, and then you can go and request it later. So that is what we're going to do today, and funnily enough, that's what happens to fix my logic apps issue. So back here, I'm back in my Visual Studio Code, and I'm going to start working on my durable function. So I'll go and hit Control-Shift-P again to bring up the command palette, then head into create function. Now you'll see there's 3 different durable function templates there. There is the HTTP starter, which is that input, the thing that triggers my functions actually running. Then there is the orchestrator, which is the thing that handles the state of my function. It makes the activities fire off. It handles the output back to the user once the job's complete. And then there's this activity, durable functions activity. That's the thing that actually, sorry, I'm pointing up there. This durable functions activity, that's the thing that actually does the work of whatever the function app's meant to do. So I think I'm going to start here with the durable functions activity. In a moment, come on. Click. Good. So it asks for a name. I'll call the, I meant to call it func activity, but I end up calling it fun activity. And the template here is real simple. It's got a parameter and then a parameter called name, and then it outputs hello name. Nice and simple. Of course, for us, name isn't what we want. We'll have address. And then the contents of this is going to be the contents from our for each loop. So I'll copy that from the previous one, place that line with my start sleep and my try block. But so at this point, this is basically exactly what we had before. I just had to change $target to $address. Yep. So again, we got some input address, we test it, we output the result. Now we did change that parameter. So one thing we do need to do is head into the function.json file sitting in the file system there. And we'll see there's a binding with the name of name. We need to update that to match what we changed the parameter to. If we don't, the whole function app doesn't even start up. It's a whole mess and really hard to troubleshoot. So just remember, if you're changing parameters in the templates, update the JSON file too. Now, this is probably the easiest one to understand. As an existing PowerShell user, it's literally just a PS1 script, nothing fancy. You got a parameter coming in, you're doing something, you're sending some output out. Next, we create a new function, and this time we'll use the orchestrator template. Again, we need to give it a name. Func orc. I never trust myself to spell orchestrator, so I go with the short one. This one has a parameter called context. That's literally the, well, it's the context for how this orchestration was started and if there was any output provided to it. The template here, once we get into it, the template here specifies a collection called output and then fires off a activity function 3 times. Each time the output's put into that output collection. So there's this command called invoke activity function that allows you to call your activity function that you've defined by name. So of course this one's expecting hello, and then there's some input. So the template has it called 3 times with 3 different cities. So it would say hello Tokyo, hello Seattle, hello London. Now it's at this point that I've realized I've spelt my function wrong. So I'll go and change that. And the name of your function is literally defined by this directory name. I do click around the files a little bit just to double check there's nothing in the JSON tying it to that name as well. But it's just the folder name, which is good. So back in my orchestrator, this template's all well and good, but it's not quite what we're after. So when we call this function, we're going to be providing addresses, which we've already seen. So I need to collect those from the context. So I'm going to have addresses. They come from the context parameter. on input. And that's literally just from trial and error and inspecting context that I've come across that. And I'm providing a raw JSON string to the input of my orchestrator, so I need to convert it to JSON. And if you'll remember, my JSON turns into a hash table which has an address key, so then I need to just get my addresses out. I don't want the whole hash table anymore. So I wrap it in brackets and just use address. Now, I could have just retyped that by hand, but I copy my for each loop from my original function. And of course, addresses instead of address. And I reference the template there to get the commandlet name. So I got invoke activity function. I call it by name, so that's func activity. And then my input is the target that I'm on for that iteration. So that the output from invoke activity function is that custom object. So it collects all three of them, then outputs the results. And I believe I double check my JSON file in a second just to make sure there's nothing special about that results file, but there isn't. So basically you just output what you need to output and the results end up with the user. So now create our final function, which is our HTTP starter. The name for this one isn't as important, and we'll see why in a second, but basically we never refer to this one by its own name. I still call it func starter to match everything, and I use the anonymous authorization. So the start of this is very similar to our previous HTTP thing. We've got requests and trigger metadata there, and using namespace system.net. And we've got push output binding at the end, which are all things that we've got here in this template. The difference is, what this one does is it starts a new orchestration. When it gets there. There we go. Okay, we'll do that first. So on the request that starts this, that calls our entire durable function as a whole, you provide a function name on the parameters. The function name is the orchestrator that is orchestrating your durable function. You specify it in the parameters, which we'll see how that's done in a moment, but then you start a new orchestration calling that by name. And if we look at the JSON file, we can see that there's a custom route in here set to orchestrator/function name. So those curly braces denote a parameter. So whatever, when we call it, it'll be /orchestrators/func_org, and it'll call our func_org orchestrator. Man, that's a mouthful. But in order for that to work, we need some input. So we specify input object. And of course, we are providing our address list from the request body. Now, instead of going request.body, I'm doing request raw body. And that's because the body ends up being this weird, I think it's a Newton JSON object, and you need to cast it to toString, and then it's just a JSON thing anyway. If I use raw body, it just provides the string as supplied, and then I can convert it to JSON myself. It was a little bit of a pain figuring out why that wasn't working when I sorted out these demos, but yeah, so then I convert from JSON. If I'm not mistaken, and you can see me jumping between different files here to just double check everything, that's everything sorted. My function app's done, or my durable function app's done. So I go and deploy it again, literally just deploying it over what I've already done. I can still rerun my previous demos because my standard function's still there. You can have normal functions and durable functions living side by side. And you notice what I do is comment out the old URI so I can refer back to it if I need to. But this time, we'll have a new one. And when I invoke REST method against this, I do expect some output. So I end up assigning that to a variable in a second. There we go. So I assign it to a response variable, and then deployment successful. So in a moment, we'll get our URI. This bit could have done with speeding up. Be careful of skipping too far ahead or we'll miss it. So you'll see now we've got our original func standard URI, and now we've got this one that instead of API slash whatever the name is, we've got API slash orchestrator slash function name. So that's what we're going to use. Now, so I'll grab that up to the slash because I need to change that anyway. And after the slash is func orc. Again, that's the name of my orchestrator function. There we go. Now, when I run this, and the first time you run your function app after deploying it, it can take a little bit because it needs to warm back up. But you'll see we've got our response back. So if I query it, I get a list of URLs. The one I care about is the status query get. And if I look at that, it's just URI. But what I can do with that is I can invoke REST method against that. So I've now triggered my function. I've got a response back. It's given me, hey, here's what you can query to get the status of your function. And there we go. I can see my status is currently running. I can see the input that I gave to it, which is that JSON. And there's currently no output, and I can see when the last update was, the status was last changed. So what this allows me to do is I can now do a while loop to keep checking that status until it finishes running. So I go while status running, go and query the status. And what's funny is I can take all the time in the world to write this because I know my function runs really slow. So we'll update the status, we'll output the status, and we don't want to spam the thing, so I'll sleep 5 seconds in between every time I check for it. So I can run that little bit there, and it'll sit there going, running until it completes. And speed up a bit. And eventually, completed. So now I can check the query. And what I'll see there is I've got my output. And I can also see that it did take about 3 minutes to complete. So I had when it was created, when it was last updated. Yeah, and I can still see what I input to trigger the thing. And there's my output. So cool, it's working. What? I'm going to flick over there right away. It's funny, I only recorded this last night, but it's already, the order of operations is already a bit foggy. Yeah, there we go. So we're going to head back to our logic apps, our logic app, and we'll update it to use our new durable function and see what the difference is. So we'll edit the existing one. And I'll add a new activity, which will, I guess actually I'll copy that body first. So I'll add a new action, search for Azure Functions again. And I just noticed that I'd seen it in the list, but it's gone. Oh no, so I have to search for it. So search for Azure Functions again, choose my MSPSUG, But you'll notice only my standard ones there. My durable functions don't show up, unfortunately, which is a real pain. What that means is I have to then go and use the HTTP action. There it is. And it means I have to do this manually, like I was doing in PowerShell anyway. So I set it to post, pop in my body, grab my URI from my code. Now, remember in the previous example when I said authorization's handled for you if you're using authorization? That's only when you're using the actual Azure Functions action. If you're using raw HTTP, you need to handle the headers and all of that yourself. Hence why I went anonymous for the demo. So I'll delete that other action, go into Compose and change that to the body from my HTTP up. Cool. So now we can go and save and run. Just double checking I did everything right. Cool. Then I can run and we'll see what the difference is. So right off the bat, once it kicks off, we can see right away we've got a waiting indicator. We've got a number of seconds ticking up. And you'll remember last time we only got the waiting indicator at the 2-minute mark when it started timing out. So now we sit here. It'll take a little bit. Eventually, at 2 minutes, it will time out anyway, but that's just a function of the view. I go and load up the runs history to watch the end of it. And eventually, turns green, took 3 minutes, which is what we expect from our run in Visual Studio. We can see status 200, which is okay. And we can see in the body is our output. Awesome, that's worked. I guess the question is why? So when we call our durable function, that response back that gives the query address is I believe it's a 202 accepted. What that tells Logic Apps is, yeah, cool, I've got your request. We're working on it, calm down. Here's where you can go and check for future updates. And then it just handles it, which is really cool. So there's one more thing. Yeah, I just wanted to see the green tick mark over there. Took 2.77 minutes, cool. I don't remember what I'm looking at over here though. Oh, sorry. So we're about to turn on the fan out, fan in application pattern. That, remembering, is where you've got your input. So for us, that's our list of addresses. And then we spin up, at the moment, we spin up an instance of our function that does the work. It completes, and then the next one spins up. It completes, then the next one spins up, which means it's all happening in series. With the fan out, fan in model, we can go parallel, but we're not actually going to see any benefit from that out of the box because each function, put it this way, on the consumption flat plan for function apps, you've got one CPU core or thread or something like that. And by default, the PowerShell worker can only do one thing at a time. So what we're doing here is going into my function app and changing the configuration to allow multiple workers in that one process. And I think multiple processes in one thread as well, so that we can get that concurrency going for a fan out, fan in. So I've headed back into function apps. I've gone into my demo function. Then on the left-hand side, this is going, yeah. Then on the left-hand side under settings is configuration. Once I wake up there a bit. Come on, you can do it. Come on. There we go. So I'm under configuration and there's all these strings there. Interestingly, there's the runtime. There's the runtime version. So that's the one that says PowerShell and this one says ~7. But what we want is this functions worker process count. It's how many processes can be spun up, and I set this to 10. Then there's another one specifically for PowerShell. And these all are in my demo code that I'll have a link to at the end of my at the end of the presentation, so you don't need to jot it down. And then there's a PowerShell specific one, which I'm about to add in, which is PS Worker in proc concurrency upper band. Mouthfuls. So I set these both to 10. You probably want to what's the word, tune these, because if you go too high it can cause issues. If it's too low you won't get the benefits that you're looking for, but when you add them it does restart your function app, so be aware of that. Now how do we actually turn our HTTP async pattern into a fan out fan in pattern? Luckily it's actually really easy. So in our orchestrator here, we've currently got this for each loop that's iterating over all of our addresses. Don't do that yet, that's the wrong order. Yeah, that's better. So we're adding a switch to the end of invoke activity function called noWait. So remember before, it was effectively waiting on each call. So it would invoke a function, wait for it to finish, start the next one, wait for it to finish. We're saying don't wait, just fire them off as fast as you can. What that means is the output of this is no longer the output of our activity function, it's metadata about that function. Sort of like when you do start job in PowerShell, you get information back about the ID of the job that's running. So now instead of storing output, I'm going to store information about those parallel tasks, and we need to explicitly wait for those functions to finish. So we use wait activity function, pass in our task. In this case, it's our collection of tasks. And then the output from that, I am going to sort. So I want all of my port statuses to be grouped together, and then within those, there we go. I want my port open. I want the port statuses to be grouped together, and then within those, the target names sorted as well. Just so I don't have to hunt through the list going, oh yeah, those ones are false, and also those ones are false. And also just to show that we don't need to, I believe, I'm not assigning the output of that wait activity, just in case it wasn't explicit. This wait activity function gets the output. So it waits for it, and then once they've all completed, it passes the output down the pipeline. What I've done here, you'll remember previously, is I had a results variable, which I stored everything in, and then I called results to output. You don't actually need to do that. You can just output directly like you would in scripts. So that's it. We've changed with adding that noWait and the wait activity, we've changed from an HTTP async function to a fan out, fan in function. I deploy it, and what we're going to see is that I actually run it twice. So the first time I run it, it's still slow. And that's just because it's sorting itself out after a cold start. But then the second time we run it, it's a hell of a lot faster. So deployment successful. Oh, and what I've remembered here is when you initially trigger your function, it can have a state of pending, and it can do for a while. So I want to handle that case because I'm just going to highlight everything and run it. As soon as it finishes deploying, come on. There we go. So it's complete. Close that, head back over to my terminal and run the thing. There we go. And so it's fired off. I go and start it. And what I do here is speed up time because it takes longer than I would have liked. You can see it took quite some time there. We fade out, it goes to complete. Now, I wasn't happy with that, so run it again. Literally making no other changes, just rerunning the thing. And this time, I do speed it up for the sake of time, but you can see from the amount of running things that pop up, it's a lot faster. So there's that pending status that I mentioned. Now it's running. And done. Super quick. Which means everything's running in parallel, and in theory, we get the same output. And if I keep the time on there, it took a minute instead of 3 minutes, which is awesome. Oh, I don't show the output. It's there anyway, look. Oh well. So let's head back to slides. So why did I get into all of this stuff? To answer that, I'll go through a couple of real-world examples of where I've actually used functions and durable functions. So my first ever function was one that does tweets out from the archive links to my old blog posts. So if you see the Windows NZ PowerShell integration, that's my Azure function. So that was my first ever case. It literally pulls my RSS feed, randomly selects one, tweets out a link. Then I have a function which I effectively use as just an API for querying support end dates for various Windows versions, and also for translating like 10.0.17763 to something I actually understand, like 1809. And then I integrate this into my reporting scripts so that I can colorize devices based on how much support they've got left. Like red means no support, blue means mainstream's gone but extended still there, and green might be mainstream and extended still there. Now the big one, which is where I learnt why Logic Apps doesn't like long-running scripts. So we've got a thing at work which is sort of a monolithic project that crosses Azure Functions, Logic Apps, automation accounts, all sorts. But at the end of the day, its job is taking an email, running some checks on it, and getting it into our ITSM system, or our ticketing system. And one thing, and it's handling specifically alerts. Some alerts can self-heal. So they'll send an email saying, hey, this status, it's cleared. But if things happen really fast, sometimes those emails come in at the same time, like, hey, there's a problem. No, it's all right. They can either come in at the same time, or the cleared one can come in early. So what I did is, if we have a cleared alert, I hold on to it for 2 minutes to give us time to process the triggering alerts. 2 minutes happens to be how long Logic Apps will wait. So by flicking that over to durable functions, that solved my issue. And that's actually what started me down the path of looking at durable functions specifically. One last example is building relationships.dev. This is a bit of a joke at the expense of a community member. But if you query it, it outputs synergies and objectives around building relationships. It's basically a lot of management BS. I haven't checked it in a while, but that should still be live. So if you invoke REST method against HTTPS building relationships.dev, you should get a response. So this, despite it taking over an hour, only scratched the surfaces of both Azure Functions and Azure Durable Functions. There's a lot of good resources online, and the quick starts on the docs are actually really good. So I've got 2 links there: TryAzure, aka.ms, TryAzureFunctions, and LearnAzureFunctions. LearnAzureFunctions take you to the docs. TryAzureFunctions takes you to a lab environment that you can make use of. I don't know if you can use PowerShell within that lab environment, but it's worth a try anyway. And yes, I highly recommend all the docs. They're great. The quick starts specifically are really awesome for both functions and durable functions. And thanks for having me. This talk, this slide deck, and the recorded demos and all the code are available on my GitHub. And the short link for that is toast.click/talks. And I believe that's everything, yes.
All right. Thank you, Josh. That was really good.
All right, I'm going to stop that so I can actually see what's happening in Teams.
Oh. Hey, there we go. All right. Hi. Does anybody have any questions?
Oh, yeah. Any questions?
Yeah, I've got one.
Oh, fire away.
Shoot.
I'm just curious. So I just came off a really big project where I knew I wanted to go serverless. I tried Azure Functions, and then eventually I had to give up and use Azure Automation. And some of the things that that caused me to do this, I mean, there were a couple. One, in debugging, I don't know if my output was getting cut off or if there was a delay in changes I made to the script actually taking effect, but the output stream seemed to be incomplete or not reflecting changes I had made.
So the output stream itself can be really annoying. Oh, and of course I deleted the thing last night, so I can't show it. That screen where I showed the previous invocations, you can click into that and see all of the output, but it does have a 5-minute lag on it, which is really frustrating for troubleshooting.
That's good to know. All right.
But that tends to be my go-to because it seems to be the most reliable way to get the output. It's just sort of the thing where I run the function, go and get a coffee, come back, and then view those invocations.
Okay. The other thing, it was funny when you mentioned the Graph API. So when I tried to use like the Microsoft Graph PowerShell module for like PowerShell, the Azure AD PowerShell module, I could not. I don't understand it, but I could not reuse the token that like I used for Azure RM to connect to Azure AD. So like with Azure RM, I could make use of the MSI, right? The actual, yeah. But I could not then take that token and use it to authenticate with Azure AD. However,
was that via Graph or the Azure AD module?
Well, 2.0, so I guess the Graph, right? Isn't Azure AD module 2.0 the Graph API?
When I mentioned the Graph module, it's the explicitly the MS Graph stuff that. Yeah, I'm not sure.
Well, that's a good point. Let me change my wording then. I'm talking about the Azure AD module, 2.0 or whatever.
Because of course the other hiccup there is it needing to work nicely with PowerShell 7 as well.
Yeah, and I kind of had to cheat there by grabbing the preview out of Cloud Shell.
Depending on when you did it, there was one really bad version of the Azure AD module, and we had to pin ourselves to an older preview version for a while.
Huh.
It might be worth revisiting it if you've got time to play.
Yeah. Well, the funny thing is, I when I went to Azure Automation, it was like everything worked.
And Azure Automation, I've used a lot as well, and it's still what a lot of my stuff's in. One thing I've found is the stuff that I've moved over to Functions has been cheaper, which
Really?
of course then the business loves. Without any code changes, I don't know if I'd picked the wrong. There's no plans on. Yeah, even now talking it through, I don't know why but it was significantly cheaper for us. It might just have been our specific use case though.
Yeah. Okay. Well, that's good.
Yeah.
Great presentation, by the way.
Awesome. Thank you.
Yeah, totally agree. That was really good.
My original cut of the presentation involved pinging those remote addresses. And I would go through the process of testing it on my local machine, and of course it all works, and then I deploy it to Azure, and what the hell, everything's broken. And I kept forgetting that Azure eats echo requests.
Right.
Which is why, if you've seen an older version of this talk, there's some live troubleshooting involved.
That's interesting. I didn't even think about that.
It's a real pain because testing open ports isn't quite as common of a thing as just sending a ping and going, hey, I'm getting a response back.
Yeah, they have their own kind of IPS that works in both directions now.
Which of course then means I need to go and find these random online websites that happen to offer SSH shells just so I can show, hey, look, it actually does work. Because I'm not opening it myself.